We get many questions from young photonics companies trying to scale up production to serve new markets and increase their turnover. And that's where Optica can help, because we have access to leading CEOs and CTOs in over 600 photonic businesses who have the wealth of experience and are willing to share their advice with others. In this series, we explore the business strategies being developed by industry leaders. We discuss the questions that young companies often find difficult to answer. I'm joined at the questioner's table by Michael Hochberg, a well-known Silicon Photonics entrepreneur. Today we sat down with Adam Carter, the CEO at Openlight. Formed as a joint venture between Juniper Networks and Synopsys, the company has a proven ability to integrate lasers, amplifiers, as well as passive components on a single chip. Adam has more than 25 years of experience at companies large and small. He's perhaps best known for being Chief Commercial Officer at Foxconn Interconnect, Cisco, and earlier at Oclaro at the time of its acquisition by Lumentum. Originally from the UK, we asked Adam to sketch what it was like when the telecom bubble burst at the start of this millennium. So we are talking about the pre-telecom bubble burst years. And in the UK, tell us more about those years in that ecosystem.
Yeah, the component industry and the fiber optic industry in the UK was pretty buoyant in the, I would say, late 70s, early 80s. A lot of research labs, the SDL was high for that, and they fed a company called STC, which then manufactured telecom systems. And in fact, Alcatel then bought SDC, and they went into the submarine business. And actually, the lasers I worked on during my first degree actually went in one of the first submarine cables that used fiber optic lasers.
Wow.
And that was pretty interesting. And then you had GEC, you had Plessey, and they all had research labs. But what happened over time was people stopped funding central research. And HP acquired BT&D because they only did multi-mode devices. They had no single mode capability. And BT&D was basically single mode. So it was a good fit. But the difference is that HP wanted to do something very, very different in the industry by coming out with transceivers. And that also meant that they had to go and develop a new manufacturing capability, which only at that time could be done in Asia. So a lot of the jobs started to migrate from the UK out into the Asia Pacific region.
Why was it only possible to do it in Asia back then?
Because that's where the big contract manufacturers were.
Even that far back?
Correct.
And was that based on labor cost? Was it based on technology? What was the reason?
It was still very labor intensive. So it was more about you had to have more people to make more product. It wasn't automated at the time. I think things have changed a lot more now. If you talk to some of the contract manufacturers on the floor at this show, they will tell you they're moving more and more to automated, and they're reducing the number of and the dependency on this on people, because machines can do things a lot quicker, but they can also do it much more reliably.
They can also generate, as we talked about last time, they can also generate a lot of scrap really fast.
That's true too. You have to have very good control processes, that's for sure.
So tell me a little bit about Openlight. Like one of the things that I've been excited about, in the integrated photonics space is that, with Silicon Photonics, we got to the point where we had pretty good control over phase, and we could get the loss down a ways, right? But what you seem to be doing with Openlight is opening up a platform where there's control of phase and there's also control of amplitude up or down.
Yep.
And from my perspective, that seems like a sea change, right? Being able to scale complexity without scaling loss. That is a hugely exciting opportunity. So tell me about Openlight. Tell me about what you're doing.
Well, I think what's interesting is it's not only a different way of looking at the technology, it's also a different way of looking at the business model. So, and this is what really excited me when I was first asked, would I be interested to come and run Openlight? And what I really liked about it was that you weren't making product, and it isn't a me too type of situation. The other thing that was very important to me, particularly with Silicon Photonics, because I was involved initially back in the 2012, 2013 time with Lightwire, was that not everybody could get access to this technology. And that meant people either had to acquire companies or they had to put money in to invest in a new startup and things like that. And everybody kept their PDKs, their process design kits, to themselves. And it wasn't open. So what I liked about this was that we could revolutionize that by offering a platform that anybody can come and use. I don't hold anything back. When I have validated and characterized a component, it goes straight in my PDK and people can use it. And what that means now is that people can now go to Tower, who's my main foundry partner, and they can download my PDK. They can either design the circuit that they want themselves, the components that they want, or they can come to me and I will also help them design that circuit. Then they just get the mask set, they port it into Tower, and then Tower manufactures silicon wafers. And what is really interesting about the timing of this is that as everybody is talking about artificial intelligence, the industry has to go through a fundamental change to support this. You cannot get all the capacity that you need in this industry today and what's going to be needed in the future. You're gonna have to be able to do it at silicon scale. And you're gonna have to work with large manufacturing operations. It's no longer a startup mentality.
So Adam, today, most of the foundries have their own PDKs. Are you saying
Correct.
that that's going to change?
I think they do have their own PDKs. The difference that we offer is we offer the fact that you can build active components into the silicon itself in a foundry process. Nobody else does that, and nobody else offers that. So yes, the success of my business is going to be measured on the strength of my PDK, and it has to be continuously updated with the latest components.
Still on the business case, for me it's super exciting, but foundries sell wafers. What do you sell? What's your product?
I sell design service. I sell IP blocks. So think about ASIC models, right? So Synopsys, who's one of my major investors, right? They make a lot of money by selling IP blocks for electronic integrated circuits. And it's $1 billion business for them, right? What we're doing is we're taking photonic building blocks and basically making a photonic ASIC. So it's a similar model. And the reason why we changed our marketing strategy last year was to get customers to understand this is not a photonics optical subassembly. This is a photonic ASIC, and it's more silicon-based than it is optically based in general terms. And that has actually started to work. People are starting to understand that, oh, I have to buy these blocks or I have to gain access to certain IP blocks to incorporate them into my design. And that's the way we make money. The other way we make money is we get a royalty fee for every wafer that Tower ships. So we help Tower design the processes, we qualify those processes, and when a customer ports their design into Tower, every wafer that ships, I get a certain percentage off that. The other thing that we've been finding as well is once you get a wafer with all these integrated circuits, people don't know what to do with it. How do you know you've got good die? Because a foundry only looks at the electrical side of it, doesn't look at the optical performance. And what Openlight has developed over many, many years is a way to do the testing at wafer level optically. And so what we've been finding is people are coming to us saying, could you test this circuit for us? And it's not necessarily from Tower. It could be another foundry.
So Adam, I'm going to make a suggestion, which is for the audience in the optics business, when they hear the word IP, most of them think patents. And that's not what you're talking about.
No.
And I think it would probably be super useful for you to take a minute or two and explain, what do people in the electronics industry mean when they talk about a piece of IP? because I think there's a lot of people in the audience here who are not going to understand what you're talking about without a more detailed explanation.
So for example, if you want to have a certain specific part of a circuit doing something, like a serializer, deserializer, people have, over the years, developed all the different electronic parts of the circuit that make up that one chip. But they are what is called blocks. And what you do is and sometimes they are patented, right? And they are protected. But then what you do is you go in and you say, I want to take this part of the SerDes block and port it into my design. And what companies like a Synopsys do, and what we're doing on the photonics side, is there are different models that you can use to generate revenue from that business. You could pay for a perpetual license, or you could renew it over a certain period of time. The other interesting thing is if you use that same block in the next generation IC, you still have to go and get the license for that one. So it's a continuing revenue stream, but it's giving everybody the access to it. And it's the companies who develop these blocks, and there are quite a few, it's not just Synopsys, but there are quite a few people who do that enable the electronics industry to grow. And my view on where we are with the photonics, it's almost like the start of the electronics industry. It's that immature right now, but it's going to grow and it's going to expand.
I see it as being sort of in the 1980s, which is right after TSMC got started, which was the first foundry, and you had the very beginnings of a fabless ecosystem, and you had the very beginnings of this IP ecosystem. So from my perspective, and you know, as someone who's been on a few different sides of this over the years, one of the things that I think is so compelling about this is that it's not actually so much about the dollar economics, it's about the risk economics, which is, yeah, I can go stand up a team to design a tunable laser. And, you know, there's a bunch of different skill sets I need to bring in, and there's a certain amount of money that I'm going to need to spend, and there's a certain amount of time I'm going to need to spend. But if I can go to someone who has a silicon-proven tunable laser that's known to work, it has the known working structure, known working control system, all the pieces are there, there's no amount of money that I can spend today to have that today, right? I could spend 2 years, 3 years developing it, but the reuse of these IP blocks means that from a time to market perspective, you get something that you just can't get any other way, because it's not a matter of running something through the fab 3 or 4 times. It's a matter of, okay, these guys have proven that this works. They have data, they have statistics, they have all this stuff. I can just grab it and drop it into my design. And that's an enormous piece of leverage.
Yeah, and I think that you have to look at how much work it takes to actually put a component into a PDK. Mm-hmm. I mean, we test an inordinate amount, we get an inordinate amount of data for each new component that we do, because we have to build the models for the PDK. And it's not going to be any good if your model doesn't do what a customer is expecting, right? So from my perspective, that's why the strength of your PDK is very important. And that's why we also say, if you use our components, we will guarantee it, because we stand by our models and we have the data to support that. And that's a very key thing.
And you run corners, I assume, as well.
Oh, absolutely. I mean, you would not believe the amount of testing we do. And I was actually shocked when I saw that. But it's because you have to, if your model isn't strong enough, then nobody's going to come and use it.
Well, or no one's going to use it a second time.
Exactly.
That's the big paradigm shift that you bring here. Until now, in the integrated photonics community, we were not offering guarantee of service. We were not offering guarantee of performance of our photonic devices. This is the first thing that you're actually bringing to the people, assuring this that the device will work regardless of what the foundry does.
If you can't
so you take over the risk.
If you can't do that, you're not a foundry. Like fundamentally, like you as a foundry, being prepared to guarantee across, certain devices that are going to yield, and you're not going to deliver the wafer if the device doesn't yield. If you don't do that, you might be an R&D fab. You might offer foundry services, but from a commercial customer perspective, you're not doing foundry work if you're not prepared to offer those
Yeah,
guarantees.
it's highly automated, right? They don't get touched. You put it in at the start and it comes out at the end as a pick. Now, we're not quite at that stage yet because we're not in full-blown production, right? We're still doing prototype runs and customers can come in and do MPW wafers and things like that. But a lot of work is still looked at to check and balance that the processes are doing what the processes are meant to do. Once it goes into production, it doesn't get basically touched by a human hand until it comes out the end.
What do you see as the biggest challenges right now from an Openlight perspective?
It's interesting. The thing that does keep me up at night is if this is successful, are we going to be able to scale? And are we going to be able to scale so that we can service as many customers as possible? And that is the thing that does worry me. We have won contracts in the last 6 months with some very big customers. And I can always, my job is to see where the cracks are and then how do we repair those and how do we move forward. So it's about how do I make it more efficient, but without losing the connection with the customer and enabling them to do what they need to do. So that is the one thing that worries me. And operationally, because I have such good partners, I'm not so concerned about that. Most startups issues start around the fact that, yeah, they have a GWiz technology, but then how do you manufacture it? How do you get it out to people in volume? I don't have that issue because I have a very good partner in Tower. And now with the Jabil announcement last week, I now have a back-end ecosystem where I'll provide the test and the burn-in support to Jabil. Jabil will then manufacture everything else. So you would go as a customer to Jabil and say, I want it in this box or in this package. They will do all that for you. I don't have to do that. I just make sure that the designs you're getting from the silicon, Tower ships them into Jabil, and then Jabil will do everything else.
Talking about the scale-up challenge, if you're working already with Tower and with Jabil, the challenge of manufacturing for scaling up is zero. Are you saying that your main challenge is scaling up testing?
It's scaling up design. And what did surprise me in my first year is the amount of design support I do have to provide. And actually that was something I wasn't expecting. And so what you've seen from us over the last 12 months is I can't scale up that fast with people. I have to run to a certain budget. But what I've done is I've started going to outsource partners for the design and the layout side. And there are a lot of small companies that are able to do that. We give them what we call a pipe cleaner. We give them a circuit and say, go design that. And then we inspect what that is. And if everything looks good, they become an outsourced partner of ours.
Michael, I'm very tempted to asking a question. I don't know if I should or not.
Go ahead. Why not?
Do you think AI is going to help with the scaling up of design?
So I think very clear from this week and from market data that you see, my belief is, particularly as you go up in bandwidth, the conventional way of manufacturing optical components is going to get harder. The yields are going to be even more difficult to achieve for high volume. And we're already hearing in the industry there's not enough supply. And that's why I think that going to a more silicon-based model is really key. I'm not saying that it's going to be the only winner, but it's definitely going to be needed to support it, and it will be part of it. This industry has always had differing technologies, and nothing has always won out. And I think that's the same here. And just look at when Silicon Photonics came out for the first time. People said this isn't a technology that's going to last. Walk around the show floor.
I mean,
how many companies are talking, we've got Silicon Photonics, right?
I can't tell you how many times I back in the 2000s, I interacted with people who just sincerely and very people I have a lot of respect for, sincerely just didn't get the point of why you would want to do optics in silicon, because their take on it was, this is a bad material for optics, right? It doesn't emit light. It doesn't have a super high mobility. The waveguides are really inconvenient to make. Like they had a bunch of good points.
Right.
And the point that I made, and I think that you made back at Cisco, was, yeah, it's a really bad material for making optics, but it's a really good material for making stuff at high complexity, right?
Correct.
And we can bring the other materials in to make it good for optics.
And the beauty of this is you don't have to go process node chasing,
right?
Either, right? And we heard this week people are going to 5 nanometer, people are looking at 2 nanometer, and oh my God, how much is a mask set on a 2 nanometer process now, right? It's a lot of investment.
Yeah.
And I think Silicon Photonics got a bad rap at the beginning because it was like people could see it would fundamentally change the way people made things. And people had already invested in using external lasers and isolators and lenses. And so that caused a bit of an inertia there.
Yeah. It was more than that. It was an antibody reaction.
Correct. You can say that. But what I would say is that is also in the industry still.
Yeah.
And my aim is to try and see people that you could actually do this cheaper and you won't have to buy as much equipment, right? And your yields are going to be at silicon yields.
Yeah.
And that's what's exciting.
It is. I distinctly remember being at, it must have been at ECOC, and it was back in the 2000s. And there was a company that I was working with where we were making prototypes for them of really cool, really advanced Silicon Photonics stuff. And the CEO was standing up and just denouncing Silicon Photonics as being fictional, nonsense, not relevant, because of course they had the big inertial investment in legacy technology, right? And
correct.
These things take a lot of time. I mean, you guys have been at this. I mean, the team from Openlight started out as
2009.
Yeah, started out as Orion, right?
Correct.
So
yeah, the team it's taken a long time to develop, and they've been through many different changes of business model.
Yeah.
This one is much different than what I'm sure the initial guys initially thought about, right? But that's why this is really interesting, is you always have to disrupt. There always has to be disruption. Silicon Photonics in 2013 was a disruptive technology. And even the people that at that time were saying we'll never use it, they're using it now because they see some of the key advantages that it gives you. And that's where we are with the technology that we offer. But people can see that there are some fundamental things that if you can get 90% coupling efficiency into a waveguide, when traditionally 30% coupling efficiency, you automatically save power because you don't have to drive the laser as hard. And you're also doing it in a very, very dense type of environment. And the real beauty of it, like anything silicon, you can step and repeat. So if you want 8 channels and I have a 4 channel, I just double it. If you want 16, I double it again. And what we're seeing is in other market segments, the number of channels is going to be very, very important. And you can't do that discreetly. And this is where this technology can really bring in benefits for that market.
One of the things you mentioned is that one of your sort of growth constraints, limiting reagents, is the ability to take on multiple design projects. When you have an organization that walks through the door, let's say it's a startup, and they want to work with you either as a customer or as a vendor or as a, in whatever capacity, right? You've been on the big company side, you've been on the startup side, like you've seen this from all the different sides. What are the positive and negative signs that you see when a startup walks through the door? What do you look for? as a signal that, yeah, this is someone we should work with, or now this is a place that we can't commit resources to?
Yeah, that's actually a very good question. And I think this is going to be even more challenging from a startup perspective as we go forward, because, if a startup comes in and says, I'm going to make optical components for AI, it's like, well, how are you going to fund that? Because the investment is going to have to be really, really high, particularly on the manufacturing side. But what I always look for when a startup comes through the door is, what are you trying to solve? And what is going to, in your product or your idea, is going to help solve that issue? If they have a clear picture of that, then that's getting the interest level up. But if it's coming in and saying, I'm doing a Me Too product, it's like, are you going to be successful? Now, in the early days of Openlight, I'd take anybody because I wanted to get it started and grow it. Now we're being a little bit more selective. But you can access the PDK yourself and go do that. So I'm not stopping anybody, and I'm not going to say, no, I won't do it, but there's the opportunity for you to go and design this yourself. But if you don't have that, your company is probably going to go through some very rocky times, right? And particularly today, investment is very difficult to come by.
You're in a unique position because you're working with the foundries, you have your customers, some of them are the hyperscalers. So you could also help those startups to train them to make sure that this solution is not only a Me Too, but is something that brings value. Is there a way that you could nurture, help those startups?
Well, the other thing, Jose, that you've got to be very careful about as well, right, is my primary job is to make sure tower is full. So the other thing is, if you don't have a clear and concise vision of what you are trying to do, you're not going to help me fill that fab. And that's predominantly what a foundry wants to do. It just wants to be running 24/7, 365 days a year at full capacity. So I think that there are startups, and we do work with startups that are doing some really interesting things, and they're getting into some of the really big companies for them to take a look to see what it's like. So there will be a lot of changes, but what I see from startups today is, if you get in bed with one of these big boys, right, it's the amount of money and the amount of resource that it takes to work with these people, it takes a lot. And that's why developing an ecosystem is so important, because you're sharing the load.
Yeah. When you talk to founders, like, what are the pieces of advice you give them?
I think the best way I can answer that is what I said to Lightwire when I first met them.
Yeah?
Oh, yeah. So when I went to see Lightwire, it was actually in one of the rooms just outside here. And I walked in, they were really excited, and they said, Adam, you're Cisco, come in. So I went into this room, and they had all this paper on the wall. And they started talking about it. And I said, how many projects are you doing?
Ha!
And they went, well, we're talking 70.
Oh, God.
And I went, no, you need to concentrate.
Did you say 70? 70?
They were working with 70 different customers on 70 different projects.
70.
And I was sat there going, you're basically going to be a jack of all trades and master of none, right? So I went to them and I said, you need to concentrate on one thing and do it well, and then people will come to you. And I've always said that. And the other thing is, don't just do it on PowerPoint presentations. Give me something that I can fundamentally play with in my lab and see it working. So at that time, it was really difficult to get a 40-kilometer, 10 gig SFP plus because of the power envelope. So I said, design me a 40 gig transmitter chip to go in an SFP for less than 1 watt.
Now, did you fund that, or was that out of their own budget?
We funded a little.
Okay, so you put something on the table.
And they came back within 6 months and showed me a working sub 1 watt, 40-kilometer SFP.
That's cool.
And they looked at me and said, are you going to buy any? And I said, no. And they
now, was it a board, or was it really an SFP form, fit, and function?
They put it onto the SFP PCB. There was no metal around it, but
okay.
I mean, you could you could do the characterization and everything else like that.
Okay.
But where the change really happened for us with that is I said, now I want you to go and give me 4 channels at 25 gig at the CWDM wavelengths to give me an LR4 100 gig optical engine.
Nice.
So Lightwire people come to you with 70 projects and you say no to 69 of them, and then they come to you with one project
the
and
one
you say,
project
I'm
I
not going to
said,
buy
"Do
it.
for me," they weren't even doing that one. But it was very diverse what they were doing. They were talking to companies on coherent, they were talking to other companies on short reach optics to take over from VCSELs and all of that, right? I mean, it wasn't clear and concise. And that's one of the problems startups have is they scattergun. And which one's going to take, right? And that's part of the issue. So by telling Lightwire to do that, and then when they came out with the 100 gig engine, that's when Cisco said, we're taking you off the street. We want that technology inside.
I'm detecting a theme. No, it's interesting. When you have a startup that comes in that has something interesting, whether it's a design partner for Openlight or whether it's the Lightwire team, you give them a test.
Exactly right. Because when you give them a test and they can do it, you know that they're onto something. If you give them a test, you're also going to tell that they're not going to get it right all the time first time. You then tell how good that team is of correcting, adjusting, and getting it fixed.
Yeah.
And that's really key.
In an ideal world, who should pay for that test? The customer or the investor?
I would say it's a bit of both. I think that an investor is going to put money in because he thinks he's going to get a return, right? So that's what they do. And although I don't invest in companies myself, I'm pretty sure they say the same thing. I mean, one of the things that I noticed when I came into Openlight was that we were dealing with a lot of smaller startup, I would call tier 2, tier 3 companies. And it was like, you're never going to fill the fab like that. And so we started a program where we started talking to tier 1s in about 5 or 6 different industry segments. And it takes time because they look at you and say, well, nobody's using it. Right? First question we got was, who's buying this?
Everyone wants to be second.
Yeah.
Correct. We want somebody else to use it and see if it works. Right? But what we're finding now is because we've come out with different types of samples of individual components and actually we do reference PICs to demonstrate the technology and people can play with that. We also work with the merchant IC guys to put in laser drivers and make sure that there's a way you can use the electronics to control the circuitry as well. That has taken some time to build up. But now what we're seeing is it's gaining traction. And the way we're seeing that is obviously with our financial performance as we move forward.
One of the things, to your question, who pays for it? Well, it's always the question of who's going to own it at the end, right? If the customer pays for it, usually the customer expects to own a big chunk of it. If the investors pay for it, they get to own it. And one of the things I've learned is that to be very shy about customers who show up and say, I want you to pass a test, whatever it is, but I want you to pay for 100%. I always like to say, well, what happened? What about if you pay for 1% or 5% or 10%? Because in that case, what you're doing as the startup is you're testing, is the person sitting across the table from me serious? Are they prepared to endure an ounce of embarrassment if this program doesn't go? Like, are they willing to put a little bit of their reputation on the line? Even if the absolute amount of money isn't that big, it's a sign of seriousness.
Yeah.
Yeah. No, and that's absolutely true as well. I think that there are a lot of people who ask, I found this at Cisco a little bit, is because you're Cisco and you've got that name, people get a little arrogant by saying, if I go and tell them to go do something, they'll just go do it because I'm Cisco.
And they will.
And you also notice that with hyperscalers now, right? Everybody's going to do everything for a hyperscaler and they don't pay for it. right? And to me, that's not the right approach. And so when I went into Cisco, I changed that by basically saying, look, if you go do this, I will get you qualified on a Cisco platform because I've asked you to do it. And that's what you'll get if you do this well. Now, wasn't always able to fund it with money, but the fact that I was willing to test, I was willing to put a lot of effort in, do the documentation, get them into all the different platforms that Cisco was producing, that was the carrot. And when you do it and you do it well, it was well worth it, right?
Yeah.
But I never would go and ask somebody to go spend money and then walk away.
Sitting with the two of you right now, if I don't ask this question, I will regret it.
Yeah.
Did Cisco test Luxtera?
Did Cisco test Luxtera?
Yes.
I don't know. Actually, I'd left before Luxtera was acquired.
And I left before he was born.
Yeah, I don't know. I
don't know either.
Okay.
I know that Lightwire had been in the company when I left Cisco and went to Oclaro. The Lightwire team had been basically in for about 4 years.
I know Luxtera probably was at a different end of the spectrum because Luxtera had been shipping product for a long time.
Correct.
Yeah.
At that point. And once you're shipping product and you're doing, say, tens of millions of dollars a year in revenue and you have stuff out in the field, it becomes less about a test and more about the numbers and about the analysis of what they actually have and talking to their customers and all that kind of thing. But one question that occurs to me as you talk about this is what you're describing from your experience at Cisco is what it's in some ways it's very parallel to one of the experiences I had at Nokia, which is when we would have startups that would come in the door, one of the things that I held as a value and that I've held as a value all along is the importance of being a good customer.
Correct.
Right? And it's very easy when you have startups that don't have a broad industry view and don't have a lot of experience in the leadership team. It's very easy to give them direction, especially if you're at a big name place, an NEM or a hyperscaler or any big end user. It's very easy to say, oh yeah, here's a thing that I think you should do. And on the one hand, there's great value in having that conversation, especially with young people.
Right.
But I've always found that it's very important to be cautious about that because what they hear, not even if it's not what's said, what they hear is if you do this, there's business at the end of the rainbow for you. And oftentimes the person who's saying it, they may not be a person who can actually write a check, right? They may not be in that role. And so, what you're describing, there's a certain discipline. If you're at a big company or you're at a big player, a big brand player in the ecosystem, when you're interacting with startups, it's very important, especially with young people in the field, to be very disciplined about making it clear where you're making a suggestion that's just sort of a general suggestion and where you're making a suggestion where it's like, if you do this, we will buy it, right? And because those are two very different conversations.
Correct. And I think that, you've got to remember as well is that when startups approach a big company like a Cisco or whatever, they're doing it because they know that's where the volume is of what they need to go sell. And so there's a lot of personal integrity at stake going back into your company, right? You're telling your investors, your board, your management team, we're going to go after and get Cisco, right? And if that doesn't happen, that can affect what happens next, right? To you personally. So I think that there's, you do have to be careful because people will go back and say, oh, Adam Carter says he's going to get me designed into all these switches and it's going to be worth like $50 million a year to us, right? And if that doesn't happen, then it's not a good situation. But again, it starts with the fundamental is what are you trying to solve? Is it differentiated enough that it's worth putting the effort in from the end customer perspective? And the way I've always looked at that is I do the same thing now as a supplier, is I try and do the same things. So I tend to be, and I tell my team, you've got to be as transparent as possible. You've got to make sure that you're not hiding things. If something goes wrong, tell them.
Mm-hmm.
Because they can react. They have a plan too. And they can see, oh, I'm not going to get this by this time. They can then react to, how am I going to get this back on track, right? And the number of companies I've heard come to me saying, well, we went to this supplier and they didn't tell us till the day they were due to ship
Yeah.
that they weren't going to ship for 2 months.
Yeah.
You can't react to that.
You used a magical word a moment ago when you talked about differentiation, and it's interesting because a lot of the time when people use that word in our industry, they think that the word technical is silent, right? And it's not, right? Because like there's technical differentiation, but there's also business model differentiation.
Correct.
And people often leave that out. I mean, one of the things that's really innovative about what you're doing is it's a business model innovation as well as a technical one.
Correct. And that was the thing that really interested me. And the reason why I came out of semi-retirement was that it was very different. But I could also see there were other opportunities where you could generate a different type of revenue stream. And the thing I really liked was I don't make product.
Yeah.
And I'm not constrained by that. By offering this open model, people can go build circuits for any type of application. And the other thing that I did realize is that lasers are becoming more and more ubiquitous in everything we're doing. And even though you might not use the wavelengths right now in certain industries, that will change. It will come. Nobody ever thought you would have lasers on your wrist.
Yeah.
5, 6 years ago, right? And monitoring your glucose level and other things in your blood, right? Nobody ever thought that. And now it's reality.
So you talked a lot about the ecosystem.
Mm-hmm.
What are some of the things that you would like to see the ecosystem solve for you? What are the things that you, in all seriousness, like what are the things where if you could reach out and wave your hand and say, I need someone to go solve this problem. What are the problems you want solved?
That's actually a really good question. I wasn't expecting that one. For me, it's about how do you expand across a broad base of foundries? It's not cheap to put this process in.
No.
Let me tell you, firsthand experience. And, you know, even though the government is talking about CHIPS Act money and things like that, there's very little for photonics.
Yeah.
Very little.
There might be more for phonics.
Exactly. But even if you look at the money, it's actually not cash. It's tax credits. It's a lot of different things that make up that money. And for me, porting my PDK into another foundry is going to take a while, and it's not cheap. And I get it that the foundries aren't willing to do that yet. But that does need to be solved because a foundry partnership is a strategic relationship to customers. They are not necessarily going to move from one foundry to another just to buy silicon photonic chips. So that's the big thing that we're trying to look at to solve. And yeah, we did go and apply for CHIPS Act money, and we haven't got any, so I can't expand that. And different foundries have different capabilities and processes, right? Which my customers might like to access.
And different cultures too.
Yeah.
Correct. Absolutely correct. And I think, you know, if you're dealing with a customer in Asia, they would prefer to have a foundry in Asia running this, right? So but small team, can't go and put all the pressure on the process guys who are still working through process issues in Tower, for example, right? I can't scale that fast. But it's the money that you need to do and the commitment that the foundry guy has to put in as well.
What do you think that is so about the CHIPS Act and not having a more impact on the photonics industry? I mean, we have explained them that if they want to continue Moore's law, if they want to satisfy the needs of AI, if they want to go with new applications with integrated electronics, they need to go to the photonics side. What's wrong? Why didn't they listen?
I can't answer for the government. I think I would say that the electronics industry, there's a lot of fundamental things that you want to make as robust and have it in the US, right? And not necessarily moving over into Asia and things like that. And I think, over the last 20 years, a lot of stuff did move over, right? Not many people manufactured anything here in this country. It was all being manufactured in Asia. And I think the electronics industry was in the fact that, a lot of the fabs and the foundries moved offshore as well. So, a lot of the CHIPS Act's money is going in building foundries here in the US, right? Intel's broken ground in Arizona. And I think that's where most of the money is going because it's not cheap.
Could it be that in the CHIPS Act, even though was supported by the government, it was driven by the microelectronics industry? And could it be that in the photonics industry, we tend to be liking working together, but we don't really have a common voice? We didn't go all together saying, we need this support from the government. Should the photonic industry make it in high volume production in the US?
Yeah, I mean, I think so, but typically what I see from photonics companies is they hold a lot of things internally.
Yeah.
And they try and do it themselves, right? And that's not an easy change to make to get groups of people to come and speak as one voice. But I do think that if something like artificial intelligence didn't move as fast as it needs to, and it's going to change the way productivity is going to be done and things like that, the government sees that, then they might do something about it. But I mean, there's been a lot of other sort of projects that have been done. Like I remember when people were talking about, let's have an indium phosphide foundry.
Yep.
Yeah.
Yeah.
Right. And I looked at that and I was actually a naysayer. I went in and I did a presentation at OIDA where I basically turned around and said, if you took all the volume of lasers, you only need to make 100 wafers a year.
Yeah.
That isn't something to start putting a lot of money in. So you've got to start off with the right model. That makes it interesting.
What have you found, just broadening the discussion a little, what have you found in your own business has changed over the last two or three years as the geopolitical environment's gotten more complicated, as the sovereign action environment has gotten more complicated? Has it had any meaningful impact on you?
Not really. I think my previous role, the geopolitical thing was a big challenge.
At FOIT?
No, Oclaro.
Ah.
Because my biggest customer was ZTE.
Mm-hmm.
And it was when the Commerce Department put them on the Federal Register, you can ship anything. And you didn't know when it was going to come off. And I spent an inordinate amount of time traveling to China to get ZTE's position. And in the end, ZTE did the right thing and were able to come off that Federal Register. But to Oclaro, that money was really important. I mean, the company could have gone under, right? And so that was very challenging. What I'm seeing today is there are one or two segments maybe where it gets a little bit dicey. But in other spaces, it's not quite the same thing. And so you can still do business. And to be perfectly honest, my whole belief is that they're going to sort this out, right? Because they have to. Both countries need each other.
That's a beautiful way of putting it. That's very optimistic, but I'm worried myself. At the Optica Executive Forum, we saw Jabil's presentation, and they talk about. Did you see? They talk about the Pingpong and
Yes.
the way that they interact with different parts of the world constantly. And in the current geopolitical situation, now we are talking about China and United States, but this could be just the tip of the iceberg. I don't see. I'm not as optimistic as you. I don't see things getting better.
So maybe I am an optimist, right? Because I think that, both countries do need each other. And I think there's a lot of posturing and things like that. And yeah, there have been some actions that have been taken, but I think at the end of the day, it potentially will get resolved. The ping pong effect that Jabil were talking about is the fact, and I've seen this with some of Openlight stuff is wafers do travel miles. Right? I wish I had the air mile account of when I first came in and saw where wafers were going all around the world. And I think that getting a central place, which is why the Jabil thing is so important, is that they will have one facility that will do all of the OSAT. And that's going to be very key because it keeps cycle times down. You're not worried about how do you get stuff in and out of different countries. And if most of it's done in North America, that's a good thing too.
I mean, bringing everything into one facility is sort of the dream, because if you're shipping from your first vendor to your second vendor to your third vendor to your fourth vendor, is putting it on a cart and shipping it down the aisle. It's a hell of a lot better than putting it on FedEx and waiting a week for it to clear customs.
Correct.
And that's not just in terms of innovation velocity. It's also in terms of just how much material you have to have in your manufacturing pipeline. It impacts the cost of doing everything.
I'll take it one step earlier, which is when I was a process engineer in BT&D, we didn't have e-beam lithography. I had to drive the wafers round 16 miles of ring road around Ipswich to go to BT Research Labs that had an e-beam machine. And I had a desiccator on my front seat loaded with wafers, and we would drive them across and then drive them back. And it took a long time.
I'll do you one better. I used to fly back and forth to Cornell in the winter to run stuff on the e-beam when we were in the early days at Luxtera. And because the flights were cheaper into Newark, I would fly into Newark and then I would drive up to Ithaca.
Mike, according to that vision, would you think that foundries and OSATs should be together, should be under the same roof?
Under the same roof is strong because, foundries and OSATs have very different business models, and they have very different margin structures, and they have very different ways of doing business and very different cultures.
But they're reasonably well located though, right?
Yeah.
So if you look in Taiwan, TSMC's in Taiwan, and you've also got ASE.
Yeah.
Which is basically they're not in the same building, but they're located within a very short distance of each other.
Yeah, I mean it's about an hour on the train, right?
Yeah.
And this is one of the reasons that clusters are so important, because you have a geographic cluster. On the one hand, there's all of the benefits in terms of people being able to move between companies and not have to relocate their families. But the other thing is that you have sort of an intellectual community of different scales of organizations and different kinds of organizations that can move things back and forth, whether it's physical things or whether it's ideas or whether it's people. I mean, one of the things that I've observed again and again is if you have two companies that are basically similar in most regards, and one of them has their manufacturing across the street from their R&D, and the other one has their manufacturing 12 hours away from their R&D and speaking a different language, the one that's across the street is going to win 9 times out of 10.
Yeah, I'd agree with that. Yes.
Yeah. All right. I know we've taken up a bunch of precious time today from you.
I've enjoyed it.
Let me ask one other question.
Okay. Is this the sting in the tail?
Yes.
Yes, absolutely. So you have a privileged view of the ecosystem as a person who's been in many different roles in many different places, and now you're sort of a neutral vendor where lots of people come to you with different things, and so you see things that other people in the ecosystem don't see. What's a really surprising, unorthodox view that you have of what the world is going to look like or what's going on, where you can see something that other people aren't seeing?
Wow, that's a very good question. I don't know. It's very interesting, right? Because when I first came into the optics industry, right, optics was always going to take over from copper. Every next speed, optics will win, and that's clearly not the case. We just saw that on Monday, right, at the executive forum. Is people are saying copper is good enough at these speeds that it's still going to be the best way to go for the shortest reach. But I do think that the sort of metrics that people are showing, I do think that fiber could get to that point, but it has to be done differently, right? And part of the biggest thing about driving costs down is you have to be able to integrate more. And I think we're going to see more and more integration coming in. And it might not just be photonics. It might be photonics and electronics. You know, a lot of people talk about CPO, and CPO will it coexist at some point? But I think the ecosystem for that needs to build out. It needs to be supported by more companies. But, you know, I've told my board that if a pluggable can be made, pluggable's going to win out all the time, because it's known commodity and people know how to deal with them and things like that. And you don't have to take a whole card out if something goes wrong, right? You can just take a module out and replace it. But I think that more and more integration is going to be needed. And the world of electronics and optics will come together more and more as time evolves. And maybe at one point in time, optics will win out.
Well, one of the things that you know, people always predict the demise of copper, right? And the thing that's extended copper has been Moore's law, because, you know, it's not like we've changed the physics of copper. It's that we're putting these massive DSPs with, you know, 40 or 80 taps of equalization that let you push very high-speed signals through very low bandwidth channels. If Moore's law is slowing, which it is, and the speed that we're innovating in photonics is increasing, which you guys are right at the center of, I think that's the thing that's going to drive the transition from copper to optics. It's that, you know, that what's extended copper fundamentally is slowing down.
Yes.
And optics is speeding up because we're getting bigger and bigger. And so
correct. And there's more and more applications that are starting to use it, right? And as that grows and the volumes are there, you do get economies of scale.
Especially if you can reuse IP.
Yeah.
Absolutely.
All right.
So the goal is to remove copper from every CPU. This was Photonics Insights. Hearing from the leaders of photonics about their preferred future and how we can help them get there faster. Michael Hochberg, Alan Carter, and to serve you, Jose Pozo. Stay tuned to this YouTube channel.